Before going further, let's first more rigorously define this recommendation system. A recommendation system is a very helpful feature, okay, for stickiness of the consumers, for inventory control, and so on and so forth. Now, in the case of Netflix, you can think of this as, say, a black box. There are inputs, there are outputs. What are the inputs? First of all, the user ID. Okay, that's your login. We're going to index user by U. Second, movie ID. We're going to index each movie by I. And then there will be, of course, a rating, which is really a number drawn from 1, 2, 3, 4, 5 stars. And we call this R sub UI. Okay, R for rating of user U on movie I. And the time that this happened, this review was entered, is TUI. Of course, there's also the review of text. Okay? And we're not going to talk much about text review in today's lecture. So you got U and I and RUI and TUI. Now, how many RUIs and corresponding TUIs are we talking about here? Actually, a lot. Think of millions of users and tens of thousands of movie titles. Of course, only a few percent of the users actually watch all the movies out there, and of or any substantial number of movies out there. And among all the movies that you actually watched, you likely will only rate a few of them. Some people like me actually rate none of them. I just don't like rating movies. But a lot of people rate, but they don't necessarily rate every single movie that they watched. Despite that, we're talking about on the order of billions of RUIs for Netflix. Now, it's a much challenging problem actually when you just have a very few rating in your database, the co-star problem. But Netflix doesn't have that problem now. All right, those are the inputs. What does the recommendation system do? What is the output then? The output primarily, of course, is the predicted rating. Let's call that R hat UI. Okay. Now, in the case of Netflix price, they actually know the true RUI. They just don't tell you, the competitor, into the price competition. In that case, you actually know the ground truth. Then you can compare your prediction R hat UI and the actual RUI. But of course, in the real operation of Netflix, they don't know the ground truth. That's why they want to recommend you to watch that movie. Okay, so you're going to just have to believe that if it works well in the test set where you know the ground truth, it's going to work well in other part of the system too. Okay. So this R hat, however, it could be a fractional number. It could be a real number. For example, 4.2 star. You cannot rate 4.2 star, but the prediction might say 4.2. So you can interpret that as maybe 80% of the chance this user U will rate it, this movie I, with 5 star, and maybe 20% of chance you'll rate it as 4 star. Maybe that's an interpretation of number 4.2. This R hat may also be going above 5 or go under 1. But then we have to clip it so that if it's above 5, it's 5. If it's under 1, we'll just call that 1. All right. How do we compare two recommendation systems? What is the metric of Figure-Murray that we're going to use to do the comparison to say, look, this recommendation system is better than the other one? What do you mean by better? Well, there are 3 levels of understanding here, going from most relevant but least tractable to most tractable but perhaps least relevant among the 3. The first level is that, of course, eventually what I care about as Netflix is customer satisfaction. If I recommend you to watch some movie, do you like that recommendation in the end? Okay. That actually is just very hard to gather data. The second level is, all right, at least I want to know what is the prediction effectiveness. Okay. If I recommend some movie, do you even watch it or not? Let alone you like it or not. Again, that's hard to collect. So we're going to look at our proxy, just like in Google PageRank. Eventually, what really matters is does the search inquirer actually find the resulting search listing useful or not. But that ultimate test is very hard to quantify and collect data about. So they use the this PageRank to say, well, I'm going to say this is the importance of nodes. Here we're going to just say, let's quantify the notion of prediction error here by looking at R hat UI and R UI. Okay. Again, how do you know R UI? In real life, you don't, but when you compare different recommendation systems, you can hold some known data as ground truth and then use that as the test data set. Okay. Well, of course, I would look at the difference between the two. Maybe this overshoots, maybe that undershoots. So it can't just be the difference. It could be the absolute value. Okay. It could also be the L2 norm, the square of the difference. Okay. So if I overshoot by 1 star or undershoot by 1 star, after squaring, they're all positive numbers, meaning positive error term. So I'm going to square them. And how many do I have? Let's say I've got a C of those UI pairs where I would like to base my comparison of recommenders on. Okay, so I will have to sum up across those UI pairs, and there are C of them, this squared difference. But since you squared things, you actually changed the scale. To bring the scale back down, people often put a square root, and that is so-called root mean squared error, RMSE. It is effectively so-called L2 norm of a vector, the vector being the error vector, difference between R hat and R across all these UI pairs. You're going to take a look at each entry of this vector, square it, then average it, then take the square root. Now, of course, when you minimize an error, whether you minimize the square root of the error or without the square root, the solution won't change. Okay, so mean square error or root mean square error, either one can be used equivalent as the objective function that you want to minimize. All right, so now we're looking at this RMSE or MSE as the quantitative metric describing how wrong your recommendations are across this set of test points. And we'll use that as the proxy for these eventual goals. So our job is not to say, give me the inputs, okay, U and I and RUI and TUI. I'm going to find a way to make recommendations and give you an output R hat. Okay. I will train this black box by looking at known R and the resulting R hats. How do I train them? By minimizing the RMSE. Then I say, all right, good, I'm done with training this black box. Now throw at me some questions where I don't know the ground truth R. Maybe you as the examiner knows the ground truth R. Well, good, and then keep it to yourself, and I'm going to make a guess R hat. Then you check your ground truths, see how good I am. That is the spirit.